Hi, I'm Terry Arden, CEO of LMI Technologies. Today, I want to show you the Gocator 3110. The Gocator 3110 is the first to combine structured blue light stereo technology with 3D visualization and feature measurement tools in a single package. We saw a need for this type of sensor while working with automotive customers who need frequently to measure assembly features on manufactured parts. This is a common challenge we find in many manufacturing industries. The solutions today are complicated, but the Gocator makes this very simple. Let's see how. Here we're showing a Gocator 3110 mounted looking down on a set of assembly features on this test target. A few assembly features are things like studs, holes. These are both on a slanted plate, and on the flat area of the plate we have slots, other holes, and various other features. Everything you need to visualize, perform measurement, and communicate decisions is performed by a web browser connected to a Gocator. In this screen, we see the setup panel where a 3D point cloud is acquired. Once the acquisition is done, a 3D point cloud appears, and in many cases, you see the point cloud as a colored height map. With Gocator, we can display this point cloud in full 3D with all the power of CAD-like tools that allow you to pan, zoom in and out, and rotate to fully examine your 3D shape. In this case, the assembly features on our test target. Beyond acquisition, the Gocator offers measurement. In the measurement panel, you select a measurement tool from a variety of tools available built into the sensor. With each tool, a property panel exists to set up the nominal dimension of the feature we want to measure, in this case a stud. A box appears which is adjusted to intersect with the feature on the 3D point cloud. So here we have our stud, it's sitting on this angled plate, and this yellow box is intersecting with just the stud portion. The tools inside the Gocator are smart enough to intersect the point cloud where I've set that volume and automatically detect the feature of interest. In this case, the stud's base radius and the tip radius. I can show this by rotating. You'll see the blue circle at the bottom and the top indicating the stud's measurements were found. Once a measurement is completed, then pass-fail conditions can be set to accept or reject the part. In this case, the part's measurement is indicating 3.028 millimeters. Our decision minimum maximum is 2 to 3 millimeters, so the part is being rejected and indicated red. If I set the boundaries from 3 to 4 millimeter variation, then you'll see that the measurement turns green. Clearly a pass. Let's look at the other types of features. We have slanted holes. So in this case we have a hole sitting on this slanted plane and we've measured its diameter indicated by this blue circle. This is another hole on the same slanted plane, but it's only a partial hole. There's data missing, yet there's sufficient data to complete the measurement. Looking at the top of this target, we have other features such as this small hole being measured. There's this small opening, it's a rectangle, measured. And finally, a large opening over here. Once these measurements are completed, all happening once again inside the sensor in one execution cycle, we can go to the output panel and assign how we want to communicate the pass-fail conditions or the raw data to the factory, either through Ethernet with a variety of protocols, such as a PLC protocol, or simple ASCII protocol, or on a serial communication line. And that's it. Gocator makes it simple. To learn more about the Gocator 3110 and the rest of the Gocator family, please visit our website at lmi3d.com. Thank you.